All right, guys, now that we kind of have reviewed a couple of important laws governing the effects on gases of pressure and volume specifically, we haven't really talked about temperature, and it's not going to be important until later. We know that pulmonary ventilation is going to be guided by pressure gradients. And from our chemistry classes, we know that things tend to move on concentrations of high to low. We have reviewed the structures of the respiratory system to know that air must enter the respiratory zones in order for gas exchanges to occur. And we know that in order for air to get there, there's going to be manipulation of the diaphragm to the pressure inside the lungs. So as we can see, every time that the diaphragm contracts, there's an expansion of the lungs. Every time the diaphragm relaxes, there is a reduction in volume in the lungs. By looking at the video about Boyle's law, we know that as the volume of the lung increases, pressure decreases. As volume decreases, pressure increases. So if we're looking at what happens when the diaphragm contracts, so as it moves down here, we know the pressure outside, if you're standing at sea level, where we are in Minnesota, that the pressure outside is about 760 millimeters of mercury. As the diaphragm contracts, the volume inside the lung increases, which leads the pressure inside the lungs to drop below 760. And this is kind of where we're seeing here at rest, where the pressure inside the lungs is equal to the pressure outside. So during rest, there is no movement of air. However, as the diaphragm contracts and the volume inside the lung increases, it drops its internal pressure even further in the pleural. So where does air move into? So this is what we call inspiration, because the pressure inside the lungs is less than the pressure outside air. So we move from a concentration of high to low. Of course, we have the other end of the scenario where the diaphragm relaxes. And in the case of the diaphragm relaxation, the volume inside the lungs is decreased, which means that there is an increase in internal pressure. So now we have an internal pressure inside the lungs that is greater than the atmospheric pressure. So pressure inside the lung greater than outside pressure. And we have what is called exhalation, and the air moves out of the lungs. So we know that movement of air towards the respiratory zones is all to the action of the diaphragm, which increases and decreases the amount of air inside the lungs, increasing and decreasing pressure as they are inversely related. We know that gas exchange happens on the respiratory zone, or the tiny sacs that we call alveoli. And we know that blood flows through these alveoli sacs as it comes from the right side of the heart as a deoxygenated blood. And as it moves through the alveoli, it becomes oxygenated blood and moves towards the left side of the heart. So it's coming, quote unquote, used from the right side of the heart and is going to be collected, quote unquote, new by the left side of the heart, where it can be pushed out to circulation. We know that as the blood comes from the right side of the heart, that it is low in oxygen because that was used by the tissues to fuel metabolic reactions. We know that the amount of CO2 that is coming from the right side of the heart is high because we know that we use oxygen to produce CO2, heat, and energy. We know that the amount of air that inside the lungs, however, is high in oxygen as it is coming from the outside. And we know that the CO2 in the lungs, about 0.03%, is pretty low. And right here we have another classical example of concentrations moving from high to low. As CO2 moves from your blood towards the lungs, and as oxygen moves from your lungs towards the blood. And here is what we have called as gas exchange. On part 2 of the class, we're going to talk about what are the influencing factors of diffusion. So there's a couple of things here that are going to influence the rate of oxygen entering the blood and CO2 leaving the blood. And then part 3 is going to talk about the actual transportation of oxygen once in the blood.